Hey guys, welcome to the Mathematics 23 review hosted by the UP Mathematics Club. It's good to have you here. And I just want to say na I actually recorded this video last. So, para sa akin, ito na yung last na video na may record ko. But sa inyo, since review slide 6 pa lang, ako rin yung mag-review. Ako rin yung magsasalita sa review slide 7. So I guess dito ko na lang din sabihin yung thanks ko mamaya. Pero anyway, let's focus muna on the given problems. So yung focus natin dito ay on differentials and local linear approximation. Meron tayong dalawang problems for differentials. And then for local linear approximation naman, may isang problem but may dalawang solution. So let's proceed with the first problem under differentials. So sabi dito, Gwen wants to paint yellow the entire outside. So take note yung keyword dito, entire outside. So yung buong nasa labas dapat siya, of a closed tin can in the shape of a right circular cylinder. So may radius siya na 4 inches and may height naman na 6 inches. So we want to make use of differentials to approximate how much yellow paint Gwen would need if she wishes the paint to be 0.02 inch thick. So for this problem, it's nice to have a visualization. So i-try ko mag-drawing kahit hindi ako magaling. So ayan, may circle tayo dito kasi gusto ko mag-drawing ng can. So right circular cylinder daw siya. So imagine nyo na lang na tama yung drawing ko. So gusto niya i-paint yung entire outside. So basically yung ipipaint niya, ipipaint niya yung top, ipipaint niya yung body niya, ipipaint niya yung bottom. So eventually, para makaka-arrive yung ayan, ang kailangan yung thickness niya 0.02 inches. So paano natin 0.02 inch? So paano natin mapaperceive yung or paano tayo makahanap ng equation para dito? Siguro yung pwede natin makonsider dito is that yung additional paint, we consider that as additional volume for the right circular cylinder or yung closed tin can natin. Kasi nga naglagay lang naman tayo ng paint sa labas. So eventually parang mag-attach lang siya sa closed tin can, and then eventually parang dagdag lang siya sa volume natin. So with that in mind, try it on your own then. Make use of differentials and then yung concepts natin from the lecture to find how much yellow paint Gwen would need to satisfy yung conditions na gusto niya from the problem. So I hope you tried it out. And actually medyo funny yung problem kasi applications din naman siya. So for the solution, we first assign variables h and r. So we'll let h be the height and then yung r naman yung radius ng closed tin can natin. So given tayo ng height equals 16 inches and yung r naman natin 4 inches. So kailangan natin mahanap yung amount of paint na kakailanganin natin to paint the closed tin can. So, gaya na nasabi ko kanina, we can represent that with delta V or yung change in V. So, yung change in V, pwede natin siya ma-approximate by dV. So, take note yung word natin ay approximate kasi hindi naman talaga sila exactly equal but malapit na yung values nila. So, note that yung volume ng right circular cylinder is pi r squared h. So, nakabigay tayo ng function v, tapos in terms of the variables r and h siya. So we make use of that. We apply that sa concept natin using differentials. So again, delta v is approximated with dv, and we know that dv is equal to v sub r dr plus v sub h dh. So this is from the lecture as well. So this is just the partial derivative of v with respect to r. Ito naman yung partial derivative of v with respect to h. And then dr is, basically we consider dr to be the change in the radius and then yung dh naman yung change in the height. So we obtained these values here by getting the partial derivative of v with respect to r and h respectively. So, ayan, ito yung function natin. Kunin lang natin yung partial derivative. Kung respect to r, 2 pi rh lang siya. Kung with respect to h, pi r squared naman. So next, we let delta r be equal to dr. So, take note na ito, mag-apply lang siya sa problem natin. Kaya sinasabi niya we let delta r be equal to dr. So since yung radius natin yung may thickness na, recall na yung sinabi sa problem, may thickness dapat na 0.02 inches, 0.02 inch, yung change in the radius maging 0.02 din. And then yung change in height naman, we multiply that by 2 kasi may thickness siya na 0.02 sa taas at meron din siyang thickness na 0.02 sa baba. Kaya we multiply by 2. So dr is equal to 0.02 and then dh is equal to 0.04. So by then, kailangan natin mag-plug in ng values. So delta v is approximated by dv, which is then equal to 2 pi times 4 times 16 times 0.02 plus pi times 4 squared times 0.04. So very mechanical na yung part na to. We just simplify here and we will obtain the value. We will obtain a value of 16 pi over 5 cubic inches. So for the second problem, yung sinasabi naman niya is that, ayan, the two legs of a right triangle are measured as 8 meters and 50 meters, with possible error in measurement of at most 0.012 meters in each leg. So we need to make use of differentials again to estimate the maximum error in the calculated value of the length of the hypotenuse. So take note na yung keyword dito ay maximum error. I think it's discussed in the lecture as well. And of course, sa discussion na-discuss talaga siya. So i-recall lang din natin and I'll give you some time. You can pause the video to try and solve the problem on your own. Okay, so at this point I'm really hoping that you are able to solve the problem on your own. But let's discuss the solution. So we first let x and y be the legs of the right triangle. So we let x be equal to 8 meters and y be equal to 15 meters. So we need to take note that we can express a function of h. We can let h be the hypotenuse so that h is a function of x and y such that h is equal to the square root of x squared plus y squared. So your maximum error in the calculated measure of the hypotenuse is then given by h of 8.012 comma 15.012 minus h of 8 comma 15. So basically ito we can just express that as delta h, and then later on we will approximate that by dh. So ayan, very similar sa problem kanina. We already know the value of dh. Pwede natin siya mahanap and may papakita natin yan in a while. So again, we need to take note that dx is equal to dy is equal to 0.012 kasi nga if we recall from the problem kanina, ayan, gusto natin yung possible error in measurement nila ng bawat legs is just 0.012 meters at most. Tapos for each leg na yan. That's why we were able to express dx and dy to be equal to 0.012. So this time we'll make use of differentials. So yung delta h in approximate natin using dh again. So dh is equal to the partial of h with respect to x dx plus the partial of h with respect to y dy. So kunin lang natin yung partial of h with respect to x. Mahanap natin siya. So it's just x over the square root of x squared plus y squared. So multiply by dx plus the partial of h with respect to y. So it's this expression here. And then we'll multiply that with dy. So we substitute values na lang. Take note na yung ginagamit natin dito. Dapat x is equal to 8 and y is equal to 15. And then yung dx and dy naman are both equal to 0.012 kasi nga 8.012 minus 8 is just 0.012. And similarly, 15.012 minus 15 is just equal to 0.012. So, ayan na yung expression natin. So, evaluating na lang dito, pwede natin i-multiply and then mag-add na lang. So, eventually, we'll arrive with 69 over 4,250 meters. So, yan yung sagot sa second problem on the topic differentials. So, proceed naman tayo sa local linear approximation. Isa lang yung problem niya, but dalawa din naman yung pinapahanap. So, we need to approximate the following using local linear approximation. So, we just need to recall kung ano yung local linear approximation and kung ano yung ginagawa natin to approximate certain values. So, eventually, maghanap tayo ng certain functions dito and mag-apply tayo ng, again, some concepts from the lecture. So, I'll pause for a while, I'll let you think, and then I'll let you try to solve the problem on your own. Okay, so hopefully at this point naalala natin kung paano gumamit ng local linear approximation. So basically mag-define lang tayo ng function, kunin natin yung partial derivatives niya and then i-apply natin yung formula na naka-indicate sa lecture. So basically yung linearization of the function na define natin at a certain point that is very close to yung values na we consider as a point. So, makikita natin yan ng mas maganda mamaya. So, ayan, for the solution ng first na pinapahanap dito. So, we consider a function. So, again, yung function natin, based talaga siya sa given. So, we let the function be the square root of x plus sine y. So, yung x and y yung magiging values na ng function natin dito. So, x here is 1.06. Yung y naman natin ay 0.04. So, we define f to be equal to the square root of x plus sine y. So, we take note that yung partial ng f with respect to x is just equal to 1/2 of x plus sine y raised to negative 1/2. So, it's equal to 1 over 2 square root of x plus sine y. And then yung partial niya with respect to y naman is 1 over 2 square root of cosine y times x plus sine y. So, we need to take note na yung xy natin from the problem is 1.06, 0.04. Kasi yan kapag substitute natin yan dito, it is exactly the value that we are looking for. So, we need to take note na 1, 0 is very close to the point that we are looking for. So, ayan, 1.06 is very close to 1 and 0 is close to 0.04. So, pwede natin ma-approximate yung function f evaluated at 1.06 and at x equals 1.06 and y equals 0.04 by the linearization of this function at the point 1.06, 0.04. So, ito yung equation niya. Yung kailangan lang natin ay ma-familiarize to. Pero may pattern naman, very mas madali siyang memorize. So, yung function lang evaluated at the point that is close to the original point. Tapos, yung partial niya with respect to x evaluated at this point. And then, multiply that with the difference between yung x minus x naught plus partial ng y evaluated at this point. Tapos, multiplied by the difference of y minus y naught. So, plugging in values, basically we just have f of 1, 0 plus, ayan, yung expression na yan. So, plug in values ulit kapag mag-evaluate tayo. f of 1 comma 0 is just square root of 1 plus sine 0. It's just 1 plus 0, so square root of 1 is 1. So dito 1 half times 1 plus sine 0 raised to negative 1 half. We will end up with 1 half times x minus 1. And then dito naman, similar process. 1 half times cosine 0 is 1. Tapos x plus sine y is 1 plus sine 0. So it's 1 raised to negative 1 half. So eventually, we will end up with 1 plus 1 half times x minus 1 plus 1 half y. So, ano pala, yung x minus 1 dito ay yung part na to dito. And then, yung y minus 0 naman yung part dito. So, kailangan natin mahanap pa siya. So, ayan, plugging in values, yung linearization of f of xy at the point 1.06, 0.04. So, yung x natin dito, we substitute that with 1.06. And then yung y dito, we substitute with 0.04. So, evaluating, makahanap tayo ng value na 21 over 20. So, para mas madali, pwede natin to ma-express in a fraction na lang. So, hindi na kailangan mag-decimals. So, for example, 1.06 minus 1 is 0.06. And that is just equal to 6 over 100. So, 6 over 100 times 1 half, madali na lang siya. 6 over 200 na lang. Tapos, simplify, making 3 over 100. So, similar dito, ganyan na lang yung process. Tapos, eventually, mas madali kasi pag fraction sometimes. So, ayan, pwede nyo gamitin yung ganyan technique. So, for the second part naman, yung function natin, since we need to approximate, balikan lang natin, e raised to 0.1 times 1.95 cube. So, we let that be e to the x times y cube. Yan yung gusto nating function for the second part. So, ayan. Ganyan yung ginawa dito. So, this time we take note that yung partial derivatives niya with respect to x and y respectively are, ayan, e to the x y cubed and 3 times e to the x y squared. So, take note na yung xy natin is 0.1, 1.95. So, it is very close to the 0.02. So, pwede natin ma-approximate yung f of 0.1, 1.95 by getting the linearization of f of xy at the point 0.1, 1.95. So, hanapin muna natin kung ano yung pinapertain na equation na to in this scenario. So, f of 0.2 plus, ayan, the partial of f with respect to x, evaluated 0.2, tapos, ayan, it follows na. So, eventually, f of 0.2 is just equal to 8 kasi nga, e to the 0 times y cubed, yung y is equal to 2. So, it's just 1 times 2 cubed, and 2 cubed is equal to 8. So, 1 times 8 is just equal to 8, plus, yung partial of f with respect to x is 8, e to the x, y cubed, so similar lang. So, that's why we have 8 here as well. And then, partial niya with respect to y naman, 3 times 1 times 2 squared is 3 times 4. So, 12 siya dito. And then, ayan, from this, we have yung linearization naman niya, or L of 0.1, 1.95. We just substitute values again, like what we did before. So, it's just equal to 8 plus 8 times 0.1 plus 12 times 1.95 minus 2. So, this is 0.1. Tapos ito naman, negative 0.05. So, since medyo mahirap yung pag-multiply ng decimals, medyo makuti siya, pwede natin i-express na lang in terms of fractions, tas mas madali na siya ma-express. And then, eventually, yung maging result natin, fraction din. So, mas maganda siya. Kasi, sometimes, for example, kapag repeating decimal na siya, baka mahirap. And, ayan, for me, mas madali lang pag fraction. But of course, it depends on whatever is given. So, ayan, this is the last part for this review. This is also yung pagtatapos ng pag-record ko because this is the last video I recorded. So, thank you so much for listening. Tapos, I'm really wishing everyone the best of luck for the exams. Hopefully, pagsikapan natin ng mabuti. And I know na medyo mahirap mag-review ngayon given the situation, pero hopefully um we have people we can look up to kapag nahihirapan tayo. Always remember na most of the time hindi kailangan na mag-isa lang tayo sa mga laban natin. So andito lang din yung math club, andito yung mga batchmates natin, and andito yung mga kaibigan natin to always help. So ayan, thank you so much for listening. I hope na makatulong yung review videos namin, and good luck sa exam.